My YouTube channel. Today we are going to see how can we conduct finite element analysis of Charpy impact test. This is a model we are going to use that. This model I have created using the SolidWorks 10, and this is as per ASTM standards for Charpy testing of materials. This is a model I have just designed using the SolidWorks software. This is the specimen. This end is being fixed, and this is the hammer that is going to blow the this specimen. I'm going to import, as usual. I have selected the structural steel material, and I have imported that material as usual method by importing option. I just edit geometry, replace geometry browse. From that browse option, I have selected this geometry of a Charpy testing method, where we have to find out the file where I have saved. I have saved in the Charpy. This is the Charpy method. I need to open that. Okay, I have already opened option, so I'm just going to for opening the workbench software. I'm going to open the workbench software. For opening that, you need to go right click and click on the edit option, so that this workbench explicit dynamics model will work on. Okay, for that, first of all, you need to explicit dynamics. You need to click on this explicit dynamics and drag it to this location, so that this explicit dynamic tools will come in the project schematic area. This is being processed, right? This explicit tools will be come under the schematic area, which I have already done here. Okay, so that I will be deleting this option because I have already added now, so this is not needed right now. So I'm just going to workbench model. As usually, as I have selected the static structural steel as the engineering data, you can see I have selected the static structural steel option. In that, specifically, I have selected static structural steel. Okay, this is the static structural steel, which has the data which I have selected. I imported the geometry. I'm going to make an analysis. I'm just going to mesh option. Okay, in that mesh option, I have just given the default resolution to 4 value. I have given the meshes. Okay, I have given the initial conditions for the analysis. I am just giving the initial conditions. This is the initial conditions which I have given as an input. Okay, these are the initial conditions. Okay, I have given. Here you can see I have given the number of step as a one step. The current step is in one. Okay, the reference energy cycle you have to calculate. Okay, you need to calculate. I have given the velocity as a 5.12 meter per second. That is a hammer velocity. Hammer flows at a 5.1 meter per second. Charpy testing. Okay, I have included the tools like which is the fixed support. These two are the fixed supports, and the velocity I have added. Okay, analysis settings you need to go through. This is the analysis settings I have done. I have included this total deformation and elastic strain and elastic stress. We will go to elastic stress. What do you have? Elastic stress. Okay, this is elastic stress that is we are going to see. The elastic stress will be like this. Okay, this is getting loaded. This is the velocity I have chosen. This is the deformation. This is the impact. I'll just locate to front view so that you can clearly understand. This is the impact. The tool is being hitting the workpiece. Okay, you can see the impact. I'll just move it. Um, this is the impact, and this is the elastic strain. I'm going to choose the elastic strain. Okay, now you can see the elastic strain. There's no unit change in length by original length. Meter gets cancelled. Um, this is elastic strain, and I'll choose the equivalent stress. One versus equivalent stress. Now you can see the one versus stresses using this FEA tool for explicit dynamics. This is the one versus the maximum one versus and minimum one versus. Approximately, this simulation takes around 27 hours. I'll look at in the information file. You can know the solution file. From the solution file, you can find out the total hours that taken for the processing of this simulation using the explicit dynamics tools. That simulation will be in the solution information. In that solution information, you can find out the what are the results you can find out. All the results will be loaded in the solution information. The solution information will be in this solution information. We can able to know what is the time taken, and all those details will be available in this solution information. Okay. We will go to the deformation again, and the deformation we have the data and all those things. Okay, in this deformation we have data and time with respect to maximum and minimum deformation, the average deformation. That's all about Charpy test. With this Charpy test, you can able to draw a graph between time versus total deformation and time versus elastic modulus. The elastic modulus can be calculated using stress by strain relation. The stress and the strain can be calculated upon the values obtained from these elastic strain results and elastic stress results. Okay, from this formula, stress by strain, you can find out the elastic modulus for the Charpy analysis, impact test Charpy analysis. Thanks for watching this video. I would like to tell you one thing. Kindly subscribe, comment, like, and share this video if you are liked it. Thank you. Thank you for watching this video.